Welcome to the deep dive. Today we're looking at something pretty critical, data analysis. It's really the key, isn't it? Bridging that gap between just having tons of data, being data rich, and actually using it well, becoming insight driven.
Absolutely. I mean, nearly every organization is swimming in information now. But data analysis, that's the function that turns the flood into something genuinely useful.
And we're looking at it from two angles today, right?
Exactly. There's this duality. On one side, it's about value generation, the bottom line, financial returns, driving business forward.
Okay.
But then there's the other side, maybe even more urgent now, risk mitigation. We're talking avoiding systemic hazards, things like bias baked into algorithms or, critical systems failing.
So we've got some case studies lined up.
We do. Across commerce, public health, and some ethical minefields, too, just to map out how crucial this balance is.
All right, let's dig into value generation first. Operational excellence seems like a good starting point. GE Vernova.
Yeah, GE Vernova, they're a great example with predictive maintenance. They use IoT sensors, loads of data coming off machines.
And the analysis turns that into predicting failures.
Precisely. It's not just about, fixing things after they break. It's about using time series analysis, anomaly detection to see problems before they happen. It shifts maintenance from reactive to predictive.
And that has a real financial impact.
Oh, definitely. The numbers are pretty stark. They've seen up to a 30% reduction in unscheduled downtime.
30%? That's huge for operations.
It is. And it translated to roughly $50 million saved in maintenance costs just in 1 year.
Wow. Okay, so that's analyzed machine data. What about customer data? How does analysis drive value there?
Well, think about Starbucks Rewards. That loyalty program, it's basically a data gathering machine.
And a very effective one, apparently.
Incredibly. It generates something like 40% of their UK revenue just from members using the app and rewards.
40%. That's massive.
It is. And what's interesting is how the collection method, the app, the reward structure itself, is sort of baked into the product experience.
Right.
It allows them to do really sophisticated behavioral segmentation.
Yeah.
They're not just guessing what you might buy. They get pretty good at predicting when, too.
But does that create a sort of dependency? Like focusing so much on app users, maybe you miss understanding customers who aren't on it. You get depth, but maybe lose breadth.
That's a spot-on point. And actually, it leads us right into the next section.
Yeah.
Because that same detailed data capture, the thing generating all that revenue, it carries huge ethical weight.
Okay, so let's pivot to risk and ethics. The Target pregnancy prediction story is pretty famous here.
Infamous, maybe. It's a classic case study in what we call inferential privacy.
Explain that a bit.
So Target wasn't necessarily collecting data points that look sensitive on their own, things like buying unscented lotion. But they use these as proxy variables.
Proxies for something sensitive.
Exactly. Their algorithm used purchase patterns, like unscented lotion combined with other things, to guess, really, that a customer was pregnant, often before she'd even told her family.
Which is highly sensitive personal information, PII.
Right. And the big lesson there is that protecting PII isn't just about locking down the data you explicitly collect. You also have to worry about what your algorithms can infer.
That inferential power is where a lot of the risk lies.
Precisely. And if we look at systemic risks, this gets really serious in areas like hiring.
Ah, yes. AI and hiring. There's been a lot of talk about bias.
There has. Research from the University of Washington looked at state-of-the-art LLMs, the big AI language models everyone's using now for resume screening.
And the findings.
Pretty concerning. The models showed a significant bias, favoring white-associated names 85% of the time.
85%.
And maybe even more shocking, they never favored black male-associated names over white male-associated names in the study. Never.
So where does that bias come from? Is it the model itself or the data it learned from?
The analysis points strongly toward the training data. These LLMs learned from vast amounts of text, including, likely, decades of resumes and hiring decisions that reflected existing societal biases.
So the AI isn't intentionally biased, but it's amplifying historical human bias.
That's the interpretation, yeah. Which really underlines the urgent need for things like fairness metrics and rigorous bias auditing before these tools are rolled out widely.
You can't just deploy the tech and hope for the best.
Absolutely not. Governance is key to preventing these risks. And that brings us to public health.
Okay. How does data analysis play into risk mitigation there?
Well, look at the CDC's Data Modernization Initiative, the DMI. It was a huge push to improve their data infrastructure and governance.
What was the goal?
A key achievement was actually doubling the amount of clinical lab data that public health officials could access for decision-making.
So getting more data faster.
Exactly. Better access, better timeliness. This directly supports what's called precision public health. It cuts down on information latency, that delay between spotting a health threat and getting the data needed to respond.
It might sound like boring background work, that infrastructure stuff, but it's crucial for better outcomes.
Totally crucial. It reduces the risk of slow or misguided public health responses.
Okay, so tying all this together, what's the main takeaway from these examples?
I think the core finding is pretty clear. Successful data analysis, whether for value or safety, is completely tangled up with ethical oversight and strong governance.
You can't separate the tech from the ethics.
Right. Just pushing technical innovation like with those LMs without thinking through the rules and the potential negative impacts, that leads directly to the kinds of problems we discussed: bias, privacy violations.
So for everyone listening, especially if you work with data, the implication seems pretty significant.
It is. If you accept that data practitioners work right at that intersection of technology and essentially public policy,
Then every choice you make about a model, about what data to use, how to train it,
it's inherently a policy choice, isn't it? It has real-world consequences.
that's definitely something to think about. What impact does that view have on how you approach data in your own work, whatever field you're in? Something to mull over.